Alright, in this video, we're going to be talking about Chapter 4, Section 1, Graphing Quadratic Functions in Standard Form. The objective for you guys, the students, will be able to graph quadratic functions in standard form. Okay. First thing I'm going to show you is we're going to graph the parent function. Alright? The reason why you have to understand what the parent function of a quadratic function looks like, because from there you can we'll be applying more stuff to that as we move on. Okay, so the first thing we do is I'm plugging these values in for x. In other words, if x is equal to -4, is x equals to -3. So I'm plugging them in here. So I'm going to put parentheses squared. Okay, so I'm going to put -4 in. So I take -4, when I square it, I get 16. Put -3 in, when I square it, I get +9. I get +4. I get +1. I'll put 0 squared, I still get 0. Alright, and so on. So when I put 1 in, I get 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay? Now I'm going to graph these, so at -4, so 1, 2, 3, 4, I go up to 16, so it's way up here. So somewhere up there. I go to -3, and it's +9. So here's 8, 10, so 9 is somewhere in between. -2, I go to 4. And then -1 is 1, so 1, 0, 0, so that's the origin. I go 1, 1, so it looks like it's going back up. 2, 4, 3, and then 9, 4, and then 16. So I'll lightly sketch it, try to make it a curve. There's no straight segments to this, right? That is what the graph of the parent function of the quadratic looks like. Okay. And we're going to keep referring to this. Now, the next part is graphing quadratic functions in standard form. Okay, so we're going to be graphing quadratic functions. Well, standard form is this: y equals ax squared plus bx plus c. You will always be given a, b, and c. Right? A quadratic function is called a parabola. That's the graph of a quadratic function. So this right here is a parabola. Right? Some people call them quadratics, but the actual name of the graph is a parabola. All right? Each quadratic or each parabola has a vertex. The vertex is the highest point or the lowest point. Okay? So for this one, my vertex is right here. So this right here is my vertex because it's the lowest point. Axis of symmetry. Okay, so we're talking about that. Axis of symmetry is that quadratic functions are symmetric across a vertical line called the axis of symmetry. This is the imaginary vertical line. All right. So if you notice here, this right here is exactly in the middle. So if I will fold this paper on this dotted line, so if I take this piece of paper and I fold it over, you will get this part will fall right on top of this part. Okay? So this right here, this vertical, this imaginary line is called the axis of symmetry. Okay? The axis of symmetry always goes through the vertex. Let's move on to the next part. All right, in this next part, there's certain things we can get from just, if they give us the quadratic function in standard form, in other words, if they give it to us in this, we can actually we can actually describe things of the parabola by this, all right? So the first part is, if a is greater than 0, in other words, is it positive? In other words, is a positive right here? Not x squared, but the number that's in front of the x squared. Is it positive or negative? If it's positive, the parabola is concave up. In other words, it opens up. If a is less than 0, in other words, it's the fancy way of saying negative. If a is negative, then the parabola is concave down, so it opens down. So either you get a valley or a hill. Now, what's nice about this is it tells us a little bit about the vertex. Here, the vertex, if a is negative, if a is positive, then the vertex will be the lowest point. Now, if a is negative, the vertex, right here, it will be the highest point, and that would be the vertex as well. All right? So by knowing what a is, positive or negative, we know a little bit more about the vertex. Is it the lowest point or the highest point? All right, so now we look at, again, we look at a. Now it says take the absolute value of a. In other words, make it positive. So if a is negative 3, we're looking at 3. If it's negative 1/2, we're looking at positive 1/2. The sign, negative, does not affect this part. So you want to always look at the positive aspect of it. So once I take the absolute value of a, is it greater than 1 or less than 1? That's what you have to ask. If it's greater than 1, the parabola is wider. All right? So what I mean by that, go back to this parent function. If a is greater than 1, like 1.5, 2, 5, 1.1, all these values are greater than 1, so that means my parabola is going to get wider. So this is the normal width. If it's greater than 1, it's going to get wider. All right? It'll be wider than the normal parabola. All right, so if it's less than 1, the parabola is going to get narrow, or I call it skinny. Okay? In other words, it'll be more in between. So that's when it gets skinny. That's if a is less than 1. Now, to find the x-coordinate of the vertex is given by the formula x is equal to negative b over 2a. So whatever a and b is, you plug it in, simplify it, and that's the x-coordinate of the vertex. All right, so for example, let's look at standard form. So we have f of x equals x squared, the parent function. All right, we'll keep it simple. What this means, a is 1, b is 0, c is 0. Because there's no b or c. So, to find the vertex, or the x-coordinate of the vertex, I take negative, b is 0, over 2 times a, which is 1. So that's negative 0 over 2, and that gives me 0. So the x-coordinate of the vertex is 0. Well, here's my vertex. The x-coordinate is 0. Right there. Now, to find the y-coordinate of the vertex is now we take 0 and we plug it back in for x. So 0 squared is 0. So therefore I get the y value. Right? We'll be practicing these. All right, the axis of symmetry is the vertical line through the vertex. In other words, it's the same formula. All right, so the vertex, to find the x-coordinate, you use this, but that's also value you get here. It tells you where the axis of symmetry, which is a vertical line. The y-intercept is c. So wherever c is, you see c, there's no c, so 0 is 0. So that's where it crosses the x-axis. Well, for the parent function here, it's the vertex, but also crosses the x-axis. This is the only point where it touches, not x-axis, the y-axis, excuse me. All right, so the y-intercept is where it crosses the y-axis.